Here's an example of a linear transformation that you are already familiar with. And so we will look at how to use a basis that we already know for the input space to find a basis that we already know for the output space. So we're going to start with the t of v equals w, and in this case, v, the input, is going to be a polynomial. This is a degree 3 polynomial. So t of v is w. We're going to find how to represent the output of this transformation, but we're going to first define that the input is a polynomial, which polynomials can be written in terms of a basis of monomials. So here's the Rn representation, or in this case, the R4 representation. Polynomials are a four-dimensional space. Cubic and lower polynomials are a four-dimensional space. And so this is the Rn vector representation in terms of the basis of monomials. And the transformation t that we are dealing with is given on the bottom of page 3 of your handout. And that's where we take the monomials and represent them as, or in, Rn. In other words, the 1 becomes 1, 0, 0, 0. And so now that's on your handout, not on the whiteboard. Be looking at your handout where it says 1, and as the arrow, 1 maps to 1, 0, 0, 0. So that's where we're taking the transformation t, like we saw on the previous video, and we apply it to each one of these basis elements. And so when we represent a polynomial in terms of Rn, what we are actually doing is we are mapping the constant to this first standard basis vector, then the next monomial to the next standard basis vector, and the next one to the next one, and then the last one, x cubed, maps to 0, 0, 0, 1. And so what we get here is the identity matrix times our vector, which is this vector itself, is w. So we've just taken this matrix, or sorry, this linear transformation t, and this transformation is what we call representing the polynomial in terms of a vector in Rn. This is an example of an isomorphism. Notice that this matrix is invertible. In fact, it's the identity matrix, and so these columns do form a basis, or these are independent, and so they form a basis. And so this is an example of an isomorphism. We say that the space of up to degree 3 polynomials is isomorphic to R4. They're both four-dimensional spaces, and this is a natural isomorphism, to go from a natural basis of monomials to the standard basis for R4.